Here are the solutions for quiz number 6, and we'll start with the first problem, which is asking us to determine whether or not the given equation has any solutions in the interval 0 to 1. Now the way we're going to solve this one is, first we're going to rewrite our equation as follows: 2x times x plus 2 equals, and we'll move the denominator to the other side, x squared plus 1 quantity squared. Now let's multiply everything out and let's square this term to end up with 2x squared plus 4x equals x to the 4th plus 2x squared plus 1, and at this point we can cancel the square terms, and we're also going to move the 4x to the other side, giving us x to the 4th minus 4x plus 1 equals 0. Now to determine if this has any solutions, what we're going to have to do is we're going to interpret this as a function f of x, which is a polynomial in x, so it is continuous everywhere on the real line, and that means we can apply the intermediate value theorem. Now we're going to have to figure out some values to plug in, and a good choice is, since we're looking at the interval 0 to 1, let's see what happens if I take f of 0 and f of 1. F of 0 is going to be, well, all of the x terms drop, so we're just left with 1, and f of 1 is going to be 1 minus 4 plus 1, so negative 2. And because this is positive and this is negative, that means that somewhere in between 0 and 1 we are going to have a 0 for this function. In other words, the original equation that we started out with will have solutions. So the correct answer is yes. Now for the second problem, we are asked to compute the derivative of the given function there. So first thing to notice is that our function is a product of 3 separate functions, right? I have an x squared, I have e to the 2x, and I have square root of x plus 1. And I know that if I have 3 functions multiplied and I have to take the derivative, this is going to be the derivative of the first times the second and the third unchanged, plus the derivative of the second times the first and the third unchanged, plus the last term is I take the first 2 functions and I just take the derivative of the last. Right, so it's very similar to the product rule for 2 functions, and we can actually expand this to an n product, right? A product of n functions, and it would look the same. So let's go ahead and apply this and see what happens. The derivative of the first is going to be 2x, and then I just copy down the remaining, e to the 2x square root x plus 1 plus, now I keep the first unchanged, but I take the derivative of the second function, and this is an exponential, so that's e to the 2x, but I also pick up an extra 2, which is the derivative of that exponent, right? And then I copy down my third function unchanged. And then the last term is going to be, I have the first and the second functions, so x squared e to the 2x, and the derivative of any root is 1 over twice that root, and because the inside function is linear with slope 1, I just multiply by an extra 1, or I can just leave that out altogether. So this should be the full derivative of f. And if we look at our choices, the only ones that match this, the only one that matches this is option A. Option B is a tempting solution because notice if I factor out an x plus 1, I end up with something that looks strikingly similar. However, there's a 2 missing from this term, which came from the derivative of e to the 2x. So that's why option B is not a correct choice. So we are not gonna select both A and B, right? Only A is the correct option here. Now, for the last problem, we're asked to find the instantaneous rate of change for that function, and that's just another way of saying find the derivative of that. So let's go ahead and do it. Right? So my function f of x is tangent of x squared plus e to the 5 e to the 2x, so we have a very complicated exponent there. And let's go ahead and calculate f prime. Over here, obviously we're going to have to use chain rule because this is a composition of several functions, especially here in this exponential term. But the outermost function is the tangent, and its derivative is secant squared of whatever this is, so secant squared of x squared plus e to the 5 e to the 2x. And now by chain rule I have to multiply by the derivative of this inside, right? So I take this now and I take its derivative and I write it in here. So it's a sum of two functions, the first of which has derivative 2x plus, now I have an exponential and its derivative is just itself 5 e to the 2x times now the derivative of this more complicated exponent, right, which again is an exponential. So the derivative of 5 e to the 2x is 5 e to the 2x times the 2 coming now from the exponent 2x. Okay, so this whole thing is the derivative of 5 e to the 2x, and that finishes our derivative. That's the entire thing. Now let's take a look at the options that we're given, and it looks like the correct choice here that has everything that we got here is going to be option E. And that's it.